My name is Matthew, and I've been doing vexiq for multiple years. So in today's special video, I'm going to go over the new VexCode 4.0 update. So by now, you've probably been prompted or forced updated your VexCode to version 4.0. And I'm here to share with you the new features and how it can help your autonomous route immensely. So far in my autonomous videos, I've been using the block code. And that's because I want to focus on the logic first, and then moving on to Python or C++. But in this update, you can actually integrate Python into the block code. So there's many more advanced Python functions that you can't do in block code that originally you couldn't combine those both. But now you can actually combine Python and block code. So here in the VexCode menu, you can see that there's a whole new menu called switch. So basically what switch does is that you can actually sub in Python inside of your block code, so you can write whatever Python you want and put it in your block code. So here, using this switch, we're going to use it to write the sensor disk, or basically using writing the brain's information onto an SD card so we can read it out on the computer. Why do we want to use an SD card for reading our sensor values in programming? So in our PID, the every loop runs for once every 20 milliseconds or 50 times per second. So that'll be hard to see with our eyes, to see what changes that we've done to the robot and how the robot responds to the changes that we've told it to do in the code. So basically, instead of using our eyes to see how the robot reacts, we can actually write down and print what the sensors say and see if there's any patterns that correspond to what we're doing to the code. So some ways we can print the sensors is one on the brain, and also we can do it on the print console. So the brain is actually really small, so it can't fit that much information on the face. So that wouldn't be very smart to put all the rotations and headings of the sensors onto the small brain, because it might overload it, and it'll also be very hard to read. So another way we can do it is putting it on the print console. But one downside with that is that in order to use the print console, your computer has to be connected to the brain for the whole time. So instead, we can use these micro SDs. We can plug it into the brain and then plug it back into our computer to get the same thing as the print console, but you don't have to plug it into your computer while the robot's running. So with this, you can see how the sensors react to the changes that you've done to the code, and it'll help you code 10 times faster, and it'll make your code a lot more efficient. So before we get into the VexCode, here's the syntax to write the file. So brain is an object instance of the Vex class, the SD card is an object in the brain, and save file is a method of the SD card. So here, the record is just a variable, so we set all the data that we want to record to record. So here's the syntax to format the output data so we can easily read everything in the file. So we set record, or our variable, to file, that's just text, plus the plus just adds it on. So counter is also a variable, and this 1.0f is how we want to format that variable. So 1.0 means there's one digit before the decimal point and 0 digits after the decimal point, and then counter is the variable. So then /n it's kind of like the enter key, it just starts a new line, and then we continue recording. So start time 6.2f, so that's how we want to format our brain.timer.time in milliseconds. So 6.2f means there's 6 digits before the decimal point and 2 digits after the decimal point. And then the /n creates a new line. So here I'm going to show you how to write data from the brain into the disk. So this is just an example. You can basically use this logic anywhere, but first we're going to use it to test the motor speeds. So first we need to set the motor velocities and the motor velocities and the motor torques. So I'm going to set them to 100. Torque is 100. And then I'm going to set the motor positions to 0. So then after that, I'm going to create the action. So basically, what we're going to do is have the motors spin 6 rotations, and then we're going to and then while it's spinning, we're going to have it put all the information of the wheel speeds into this card so we can read it. So reset timer, and then we need to spin these wheels forward, and then now we're going to add the switch in. So now it's going to start to record. And then we're going to create a repeat until loop. So we're going to repeat until the motor position is greater than 6. So the motors will stop spinning once their position in not degrees, their position in turns are greater than 6. So while here, while inside the loop, while the robot is still spinning, we're gonna actually record the left wheel and right wheel speeds. And then once the motors have spun 6 times, I'm gonna stop the motors. And then once it's done, I'm gonna record the end time and then put it onto the SD card. And that's basically it. So just to go over, we spin the left and right wheels until it reaches the position 6, and while it's spinning, we're always recording this. So as I said, this loop runs once every 20 milliseconds, or 50 times per second, so that's a lot. And then once we're done, we stop the wheels, and then when we record the end time. Oh, I said end time. And yeah, that's how we record the brain's information and the sensor information and put it onto this SD card. Here I'm gonna put my micro SD card into the robot, and then we're gonna turn on the program and run. So now that the program's done, I'm gonna turn it off. I'm gonna take out the micro SD card and let's go read it. So here I have the SD card that I plugged into the robot, and now I'm gonna put it into my computer so we can read it. So you see here's the speed.txt, and see here the wheel speeds. So as you see here, the wheel speeds are fluctuating a ton, like 60, 70, 80, there's 60, there's 80, it changed 20%. just in 20 milliseconds. So I don't think this using this is a good way to test the motor speeds, because it keeps fluctuating. So I think we'll try to use the total time instead to evaluate for the best speed. So I want the program to run multiple times, and so I'm going to create a counter variable. So variables, we have a counter. So when it started, I'm going to set the counter to set counter to 0, and every time I press the touch LED, I'm gonna change the counter by 1 and reset the wheels. So variables, change counter by 1, and then reset the wheel positions. So every time we run the with the counter, I want to create a new file. So on top of this, I'm gonna add another switch. So what this does is that it creates a new file. File name equals 100 speed plus percentage 1.0 f percentage counter plus .txt. So what this does is that it creates a new file every time it has a new counter. So then at the end, instead of saying speed.txt, it needs to be called file name. So here we have multiple run speed settings. We have 75, 78, 80, 85, 90, and 100. So let's go take a look. So the end time here, end time here. So with all these, I made a table. So let's go take a look at the table. So as you see here, at 100% velocity, the runs take an average about 4 seconds. But same with the 90, and same with the 85, and same for the 80. So from 180, the run times are pretty much the same. But there's a pretty significant jump between 80 and 85. So then I decided to run 75, and you see it still changed from 80 to 75. So you see here, 80 is probably the maximum speed that the robot's going to be going at, because from 80 to 100 the run speed actually doesn't change. So from now on, I'll probably just set my max speed to 80, because that takes the same time to run as the 100, and it's a lot more accurate. So thank you guys for watching. So the ability to write to the disk is a game changer for the autonomous program, because it helps you code a lot more efficiently, and it makes your program a lot more precise. So it lets the number speak for itself. It helps you see what you change to the PID, because it can be hard to see with your eyes sometimes. And yeah, no more guessing.